Welcome to today's lesson. And today we're talking about the Laplace inverse or the inverse Laplace. And our main focus in this video is to be able to find the Laplace inverse of this particular question here. Alright, so before that, note that when we have a function f of t, the Laplace, so this means the Laplace of our function f of t is a certain f of s, right? And when we want to find our f of t, that means we have to find the Laplace inverse of our f of s. So finding for our f of t is the Laplace inverse of our f of x. So you can see that here we have f of s here. In this question we have f of s here. So we are supposed to find for our f of t. We are finding the Laplace inverse of f of s. That's what the question says. So that means we can write our f of s as we can see here from the question. Right, so when we get here, what we do is that we resolve this expression into partial fractions. Okay, so since we have linear factors here, that means resolving this into a partial fraction is going to be a over x, b over s plus 3, c over s minus 4. I hope you get that. So a over this, b over this, and c over that. So after that, you realize that we have the same denominator, right? So we can decide to find the LCM of what we have here. So the LCM of what we have here is the same as what we have here, right? So after finding for the LCM, then you realize that here we have s here, so we have to multiply a by s plus 3 and s minus 4, then b by s and s minus 4, and c by s and s plus 3. So that's what you can find here. Okay, so when we get here, then the next thing we do is that we expand, right? So remember the left hand side is not changing. So when we expand s plus 3 times s minus 4, we get s squared minus s minus 12, as you can see here, and this gives us s squared minus 4s, and this gives us s squared plus 3s. So we can do our multiplication. So when you multiply through, we are going to get this, as we can see here. And after getting this, the next thing we do is that we group like terms. Okay, so realize that we have x squared, s squared, s squared here. So we group that like term here. We have s, another s here. So that's what you can see here. And we have minus 12a. So after grouping like terms, then we compare coefficients. So we do comparison. So when you compare coefficients, you realize that when it comes to the left hand side, the coefficient of s squared is 4. The right hand side, that of s squared, is a plus b plus c. So that means the first equation we get is a plus b plus c equals 4. So that happens to be equation 1. To get our second equation, we compare the coefficient of s at the left hand side to that of s at the right hand side, and that gives us negative a minus 4b plus 3c equals negative 17, and that's being equation 2. Then the next thing is that you realize that we have a constant here because there is no s attached to what we have here, and we also have a constant here. So that means you have negative 12a equals negative 25, and that happens to be equation 3. So after getting these three equations, then we are supposed to solve it simultaneously for the values of a, b, and c. So realize that from equation 3, we have minus 12a equals negative 25. So that means we can simply find for our a, which should be 25 over 12. So that means we have our a. We now have to find our b and our c. But from equation 1, we have a plus b plus c equals 4. And now we have a to be what? 25 over 12. So we can make that substitution here. And after making that substitution, we have b plus c will be equal to 4. So when this crosses, we have negative 25 over 12. When you do that commutation, you get b plus c equals 23 over 12. So you can decide to leave it in that way or multiply through by 12. So when we multiply through by 12, Then we have 12b plus 12c equals 23. And this happens to be equation 4. Then also note that from equation 2, we had negative a minus 4b plus 3c equals negative 17. But now we have the value for a, right? So this is the same as negative 4b plus 3c. We decide to bring the a to the right hand side. So we get negative 17 over a. Then here when we substitute the value of a into the right hand side, then we get this, right? When you get this, we can decide to multiply through by 12. And multiplying through by 12 gives us this resulting equation as you can see here. And this is equation 5. So we've been able to find the value of a, which we have to be 25 over 12. And now we have two simultaneous equations of two variables to help us find for our b and our c. So these are those two equations. So when you solve these two equations simultaneously, you're going to get b to be 62 over 21. You're going to get c to be negative 29 over 28. Okay, so that means now we have the values for a, b, and c. Recall that a was 25 over 12. Then we come here. So remember that when we were decomposing, we said that the whole of this is equal to a over s plus b over s plus 3 plus c over s minus 4. So since now we have our values for a, b, and c, we have to make substitutions. Okay, so we come here. So finally we have this is equal to, so now the whole of a is 25 over 12. So we make that substitution. The whole of b is 62 over 21. We make that substitution. And the whole of c is negative 20 over 28. So we made that substitution also here, and we have this. So when you have this, remember this was our f of s, right? And it's the same as this. So now we can see our f of s is this expression we have here. So now we are coming to find the Laplace inverse of this expression, which makes it look so simple for us. So remember that Laplace inverse of f of s is equal to f of t. So we have to find the Laplace inverse of 25 over 12s plus 62 over 21 times s plus 3 and minus 29 over 28 times s minus 4. Okay, so that's what we have. Then you know the Laplace operator or the inverse Laplace operator, the inverse Laplace operator is a linear operator. So that means we can take it through our expression as we have here. So this is the same as Laplace of 25 over 12 times 1 over s. Note that this is the same as whatever we have here. So this is also the same as Laplace inverse over 62 over 21 times 1 over s plus 3 and plus, so Laplace inverse of negative 29 over 28 times 1 over s minus 4, right? And you know we can put the constant out. So when you put the constant out, we are going to get 25 over 12 times Laplace of 1 over s, then plus 62 over 21, then times Laplace of 1 over s plus 3, Laplace inverse, then minus 29 over 28 times Laplace inverse of 1 over s minus 4, right? So to find Laplace inverse, we should note that, so I've written the answer here, but let's note that the Laplace of a is a over s. So you realize that now this is the a here happens to be our f of t, and the f of s here happens to be our a over s, right? So here our a happens to be 1 here. So that means that if the Laplace of 1 is 1 over s, then the Laplace inverse of 1 over s will simply be 1. So you are going to have 1 here. The whole of this gives us 1. And 1 times 25 over 12 is 25 over 12. So that's why we have that one here. Then when it comes here, Laplace inverse for 1 over s plus 3. We know that the Laplace of EAT is 1 over s minus 3. So that means that the Laplace of e minus 3t is what is going to give us 1 over s plus 3. So the Laplace inverse of this expression here gives us this. So that's the reason we have e minus 3t here, and you should be able to use that explanation to get the reason we have e raised to the power 4t. So this expression we have here happens to be the Laplace inverse of that question. And you realize that this is in terms of what? F of what? T. Alright. So thank you very much. This is how we go about things when you are being asked to find for the Laplace inverse of certain expression.